So let us see the next one, that is the grade of the steel. In the last video, we have seen what is grade of concrete. What do you mean by grade of concrete? Grade of concrete means 28 days characteristic compressive strength. And similarly, what is grade of steel refers to is, grade of steel refers to characteristic tensile strength. Okay, what does the grade of steel represents? Characteristic tensile strength. And when you conduct the tension test for the mild steel, okay, when you conduct the tension test for the mild steel, you will obtain the stress strain curve. And in the strength of materials, you have seen that stress strain curve. So whatever the stress at the lower yield point is there, okay, stress at the lower yield point is there, that is taken as the tensile strength of mild steel. Okay, so for the mild steel, what is tensile strength is, that is the stress at the lower yield point. And now if you take the HVAUQ bars, okay, suppose if you take the HVAUQ bars, in that you will not get definite yielding point. Okay, so if you consider the stress strain curve, so stress is usually taken on the y-axis and strain is taken on the x-axis. And for the HVAUQ bars, the stress strain curve will be like this. That means initially the variation will be linear, then after certain point graph will be like this. Okay, graph will be like this. So this variation is linear initially. Remember this. This is linear complete. Now here in the HVAUQ bars, you do not have the specific lower yielding point. That's why what we do is, at the strain of 0.002, we draw an offset like this. Okay, at the strain of 0.002, we draw an offset like this. And at this point, whatever the stress is there, that is considered as the tensile strength of HVAUQ bars. Okay, so for the HVAUQ bars, what is the tensile strength is, that is the stress at the strain of stress at 0.002 proof strain. So this stress is called as 0.2% proof stress, because whatever the 0.002 strain is there, that is also called as 0.2% strain. So whatever the stress related to this 0.002 strain, that is called as 0.2% proof stress. So for the HVAUQ bars, 0.2% proof stress will be the tensile strength. For mild steel bars, stress at the lower yielding point will be the tensile strength. So based on this tensile strength, we will decide what is the characteristic tensile strength for the given steel, and from that we will decide what is the grade of the steel. And usually in RCC we use three types of grades of steel. They are Fe250, Fe415 and Fe500. Of course sometimes we use Fe550 also, but they are very rare. Mostly these three types of steels are used in the RCC. Next one, elastic modulus of concrete. And in the strength of materials, you have seen how to determine the elastic modulus. So elastic modulus means nothing but, what do you mean by elastic modulus? Modulus means slope basically. Okay, what do you mean by modulus? Modulus means slope. So slope of the elastic region. Okay, slope of the elastic region, that is called as elastic modulus. So now if you take the stress strain curve of concrete, okay, I am saying stress strain curve of concrete here because here I want to determine the elastic modulus of concrete. So that will be like this. So initially whatever the variation is there, that will be parabolic up to this point, parabolic up to the strain of 0.002, and from this strain, the stress varies linear. The stress do not show any variation here. Instead, it will be constant. So beyond the strain of 0.002, whatever the stress variation in concrete is there, that will be constant. Remember that. So now, elastic modulus of concrete. So here we have the stress strain curve. Now we have to determine the elastic modulus. So how to determine that? Okay. Now when you want to determine the elastic modulus, you have to determine the slope of this line. But as this variation is parabolic, slope at different points will be different. Okay, here the slope will be different, here the slope will be different. That's why what we can do is we can determine three types of modulus here. So first you can draw a tangent at the origin. Okay, you can draw a tangent at the origin, and that tangent is called as initial tangent. Okay, whatever the tangent drawn at the origin, that is called as initial tangent. So if you determine the slope of this initial tangent, slope means modulus means what I told, slope. So if you determine the slope of this initial tangent, that is called as initial tangent modulus. Okay, then here what we can do is we can draw a we can take a point at the stress of FCK by 3. Okay, at the FCK by 3 stress, take a point on the stress strain curve, and to this point if you connect to, on at this point if you draw a tangent. Okay, so at this point if you draw a tangent and if you determine the slope of this, so this is called as tangent here. So if you determine the slope of this, that slope is called as tangent modulus. Okay, and you can draw another line here. What is that is, so whatever the stress at FCK, whatever the stress of FCK by 3 is there, that if you connect to the origin directly. Okay, that means instead of drawing a tangent there, if you draw a, okay, if you draw a line joining this point to the origin, this point to the origin, so this line is called as a secant, and slope of this secant is called as what? Simply secant modulus. The slope of the line is called as what there? Secant modulus. Okay, so like this you can determine three types of modulus for the concrete. Okay, suppose if the variation is linear, then what happens is all these three modulus will be same. Okay, if the variation is linear here, then all the three modulus will be same, but here the variation is not linear, instead it is parabolic. That's why we can determine three types of modulus here: initial tangent modulus, and secant modulus. So when I say initial tangent modulus, you have to draw the tangent at the origin and you have to determine the slope of that. When I say tangent modulus, you have to draw the tangent at the stress of FCK by 3. When I say secant modulus, you have to draw the secant at the stress of FCK by 3. Okay, so now among these three types of modulus, which is most suitable for the concrete is secant modulus is most suitable for the concrete. Okay, so which type of modulus is most suitable to determine the elastic modulus of the concrete? That is the secant modulus only. Okay, so now among this now based on the IS 456, what is the formula for this secant modulus is, what is this formula for elastic modulus is EC equal to 5000 root FCK. Okay, what is the formula for the secant modulus? EC equal to 5000 root FCK. Okay, so whatever this secant modulus is there, that is also called as static modulus. Okay, secant modulus is also called as what? Static modulus. Okay, so this is about the stress strain curve of the concrete and elastic modulus of the concrete. So what is the formula to determine the elastic modulus of the concrete? 5000 root FCK. Okay, 5000 root FCK. And which of the modulus is most suitable to determine the elastic modulus of the concrete? That is secant modulus or static modulus. Okay, so that is about the elastic modulus. So next one is the creep of the concrete. And what is creep is basically creep refers to long-term deflection. Creep refers to what? A long-term deflection. That means just take a beam like this and apply the load on the beam. When you apply the load on the beam, immediately beam is subjected to some deflection like this, which is called as short-term deflection. And if you keep the same load, if you keep the load, if you fix the load here, that means you are not removing the load, you are keeping the load for a long time, then this load will cause additional deflection with duration. That deflection we are calling as a long-term deflection. Okay, so immediately after applying the load, whatever the deflection you obtain, that is called as short-term deflection. and even though that load is constant, with the time there will be some additional deflection which is called as a long-term deflection. Okay, so now whatever this creep is there, that can be called as a time dependent strain. Okay, creep is called as what? A time dependent strain. Okay, why I am calling as time dependent strain is because deflection is taking place with time. That means suppose measure the deflection after 1 day, 7 days and 28 days. So with the increase in duration, what happens to the deflection here? Deflection increases. So when I say deflection is increasing, that means the strain is also increasing, and this strain is increasing with respect to the time. So that's why creep is called as what? A time dependent strain, and creep is what? A long-term deflection. And remember that when I say creep, what must be the loads here? Loads must be static, they should not change. Okay, so creep is the long-term deflection under static loads. Okay, very important question. It was given in number of exams different times. Okay, then whatever this creep is there, that depends on age of loading basically. Okay, creep depends on what? Age of loading. So what do you mean by age of loading is, so immediately after casting a beam, suppose, okay, immediately after casting a beam, you will not apply the load on the beam. Instead, we will apply the load maybe after 7 days or 28 days or 1 year, like that. So at whatever the duration the load is applied on the concrete, that is called as age of loading. Now in case of actual structure, when the load will be transferred to concrete is upon removing the formwork. As long as formwork is there, formwork will take care of the load. But once if you remove the formwork, then concrete starts taking load. Okay, so age of loading means the time at which formwork is removed. Formwork is removed and load is transferred to the concrete. Okay, so now this creep coefficient, whatever the creep is there, it is generally denoted as creep coefficient. So this creep coefficient depends on age of loading. The creep coefficient depends on what? Age of loading. Suppose if the age of loading is 7 days, then creep coefficient will be 2.2. Okay, 2.2. And if the age of loading is 28 days, creep coefficient will be 1.6. If the age of loading is 1 year, creep coefficient will be 1.1. So like that, with increase in age of loading, what happens to the creep coefficient? Creep coefficient decreases. Okay, so remember this point, very important. With increase in age of loading, whatever the creep coefficient is there, that will what? That will decrease. Okay, now whatever the creep is there, I am saying that it is the long term strain. So now you can determine the creep modulus. You can determine the creep modulus using this creep coefficient. So for that creep modulus, the formula is, suppose creep coefficient is denoted with theta, then creep modulus is EC by 1 plus theta. Okay, what is creep modulus formula? EC by 1 plus theta. And what is this EC is? That is nothing but we have seen here, EC means elastic modulus of concrete. So if you know that elastic modulus of concrete and if you know the creep coefficient, then you can determine the creep modulus. Okay, so this is about the creep of the concrete. So next one is the workability of concrete. So basically what is workability is, it is the ease of handling the concrete. Okay, workability means ease of handling the concrete. So now in case of RCC, or else in case of plain concrete, depends on the mode of the work you are doing, or else depends on the placing condition, the degree of workability you require varies. Suppose if you are working at greater depths, suppose this is the ground level and you are working at greater depth here, you obviously require the concrete of more workability. Okay, in this case we require the concrete of more workability because here placing is difficult at higher depths. Okay, so for this purpose we need to use concrete of high or very high workability. Suppose if you are working on the ground level itself and you are casting a very thin section, okay, you are casting very thin section, then whenever you place the concrete here, it should not flow, it should be there only. So in this condition, whatever the workability you require, that will be less usually. So totally 5 degrees of workabilities are there as per IS 456 2000, and these conditions you can get in clause number 7.1. Okay, if you see the clause number 7.4 7.1, you can find this you can find these types of workability here. So here for blinding concrete, shallow sections and pavement using pavers. Okay, blinding concrete, shallow sections and pavement using pavers, we require the very low degree of workability. That means the slump will be usually 0 to 25 mm. Okay, so for this three purpose, blinding concrete, shallow sections, pavement using pavers, we require the concrete of very low workability, that is 0 to 25, because shallow section means very thin sections. So when the sections are very thin, upon placing the concrete should not move there. That's why slump value should be very less. Next, for the mass concrete structures, lightly reinforced sections and hand placed pavements. For pavement using pavers, it is a very low workability, but for hand placed pavements, it is the low workability. Then for canal linings, strip footings, we require the slump of how much? 25 to 75 mm. Similarly, if you take the heavily reinforced, for lightly reinforced, you require the low workability, and for heavily reinforced, because when it is heavily reinforced, reinforcement will be congested here. When the reinforcement is congested, it is difficult to place the concrete. So, in that condition, we require the concrete of we require the concrete of more workability. That's why we have to use the slump of 50 to 100 mm for the heavily reinforced section. And if you are using the slip form work and pumped concrete, okay, if you are using the slip form work and pumped concrete, we require the concrete of medium workability with slump of 75 to 100 mm. And if it is the trench fill and in situ piling, when I say trench filling, this kind of work it is. So in that condition, we require the concrete of high workability. And trimmy concrete means sometimes when you are working at higher depths, we place a trimmy pipe at the depth, and we supply the concrete through the pipe in which concrete has to flow here. So for the flow of concrete, you require a very high slump. So for the trimmy concrete, we require the concrete of which slump? Very high slump. So like this, with increase in depth of working, or else with increase in percentage of reinforcement, workability of the concrete required increases. Okay, so this is about the workability of the concrete required as per IS 456 clause number 7.1. The next one is the durability of the concrete. So basically, if you use concrete in different condition, then its durability may varies. Okay, suppose if you are using certain type of concrete in normal condition. Okay, normal condition. That means normal condition means very less rainfall is there. Okay, and no coastal region. So in that condition, this is one condition, and you are using concrete in another condition, suppose extreme condition, and in that extreme condition, whatever the concrete is there, that is subjected to tides continuously, seawater tides continuously. So in this case, concrete will be subjected to changes easily or not? Yes. Okay, concrete will be subjected to different attacks easily here. So if you use the same concrete in normal condition and extreme condition, its durability varies here. So for that purpose, IS 456 table number 3, 5 types of exposure conditions are defined. Okay, if the concrete is placed in different condition, it will obtain different, it will get different durability there. So 5 type of exposure conditions are defined here. What are the 5 types? Mild, moderate, severe, very severe, and extreme. Okay, so now just see that. Suppose a concrete surface is there. Okay, concrete surface is there, and this concrete surface is completely sheltered. Concrete surface is completely sheltered. Then whether there will be any problem to this concrete when it is sheltered here? No. And one more thing is, this concrete is not located in any coastal areas. Okay, concrete is not located in any coastal areas. So for this case, durability will be obtained easily. Okay, so such kind of condition is called as a mild condition. Such kind of exposure condition is called as what? A mild. So when I say mild condition, that is for the concrete surfaces protected against weather or aggressive condition. Okay, here upon here when the rain takes place, you are restricting the rain to in contact with concrete by using the shelter. So this condition is called as mild, but remember that when I say mild condition, concrete should not be there in the coastal areas. Second one, moderate condition. Okay, now this same concrete is there, and here this concrete is sheltered from the severe rains. Okay, severe rains are taking place, but if the concrete is sheltered here, then such condition is called as moderate. And suppose concrete is in normal zone, concrete, there is no severe rain here. Okay, there is no severe rain here, there is normal rainfall only, but no shelter is there. Okay, no shelter is there and normal rainfall is there. So in that condition, again it is called as moderate. So concrete exposed to condensation and rain and no shelter is there, that means exposed means no shelter is there, so such one will be the moderate condition. Then concrete continuously underwater, suppose a river is there and what concrete is placed in the river like this. Okay, so concrete continuously underwater, river water, this is I am saying, not the sea water, river water. So this kind of condition is again moderate. Then concrete in contact are buried under non-aggressive soil. Concrete is buried under soil here. Concrete is buried under soil here. But it is which kind of soil they are saying? They are saying it is non-aggressive soil. Again, it comes under the moderate condition. And concrete surface sheltered from saturated salt air in coastal areas. So in coastal areas, basically what is the problem is you will have the saturated salt air. But if that concrete is sheltered from the saturated salt air, then it comes under the moderate condition. So under moderate condition, totally 5 things are there. First one, concrete surfaces sheltered from the severe rain. Second one, concrete exposed to condensation and rain. Third one, concrete continuously under water. And fourth one, concrete buried under soil, non-aggressive soil. And fifth one, concrete surface sheltered from the saturated salt air. Then under severe condition, what comes is first one, concrete surface exposed to the severe rain. So here severe rain is taking place, but no shelter is provided. If the shelter is provided, it will come under the moderate condition. If severe rain is there, but if it is not sheltered, then it comes under which condition? Severe condition. And concrete completely immersed in seawater. If it is immersed in river water, then it comes under the moderate condition. But if it is immersed in the seawater, then it comes under the severe condition. Then concrete exposed to the coastal environment. Okay, concrete is there in the coastal environment, but if it is sheltered, then it comes under the moderate condition. But if the concrete is exposed to the coastal environment, that comes under the severe condition. Next one, very severe condition. Concrete surface exposed to seawater spray. Okay, suppose a concrete is there in the coastal region, and what are the seawater is there, it will form some sprays here. If that spray directly comes on contact with the structure, that spray directly comes on contact with the building, so whatever that concrete is there, that comes under the very severe condition. And similarly, concrete in contact with buried under aggressive soils. If it is buried under non-aggressive soils, it is a moderate condition. If it is buried under aggressive soil, then it is the very severe condition. Then surface of members in tidal zone. Surface of members in tidal zone means, suppose if you take the port, if you take the port, whatever the concrete is there here, that will directly in contact with the tides like this. So tides will continuously hit the concrete like this. This condition is called as extreme condition. Then members in direct contact with liquid or solid aggressive chemicals. Suppose pipelines are there, concrete pipelines are there, and in that dangerous chemicals, aggressive chemicals are flowing. So such kind of condition is also called as extreme condition. So these are the 5 durability conditions under which, these are the 5 durability conditions as per IS 456 2000 table number 3. Okay, very important these things also. So next, this is the table number 5 in the IS 456. So here in the table number 5, they have given the minimum cement content, maximum free water cement ratio, minimum grade of concrete, for different exposure conditions for both plain concrete as well as reinforced concrete. Now from this table you can say that the maximum free water cement ratio you can use in the plain concrete is how much? 0.6. Okay, maximum water cement ratio in plain concrete is how much? PCC is how much? 0.6. Suppose if it is RCC, then it is how much? 0.55. Okay, then what is the minimum grade of concrete used in the RCC? Okay, minimum grade of concrete used in the RCC is M20, whereas PCC is how much? PCC, it is not specified. That means you can use M5 grade of concrete, M7.5 grade of concrete, whatever the grade you want, you can use in the PCC. But when it comes to RCC, the minimum grade of concrete we have to use is how much? M20. Suppose if they ask you like for concrete under the seawater, for plain concrete under the seawater, then it is M20, because plain concrete under the concrete under the seawater means it comes under which condition? Severe condition. So if the concrete is placed under the water, if it is PCC, minimum grade of concrete is M20. If it is RCC, minimum grade of concrete is M30. So like this, different values are specified here. Okay, different values are specified here for different exposure conditions for both plain concrete and reinforced concrete. So whatever the values I have rounded off here, those values are very important. Okay, so this is about the different properties of the materials required for the concrete, and in the next video we are going to see the design philosophies of RCC.